All right, so now looking at how to do the half-life part of this. So it says Krypton 89 has a half-life of 3.19 minutes and 15 minutes has passed. So we're trying to find out the relative percentage of parent and daughter isotopes present. So if you look at our equation, we're saying, well, N, being our current amount, is equal to NO, our starting amount, 0.5 or a half to the power of N, where N is the number of half-lives that have passed. So if you want to solve for that, we're going to start off with saying, well, 15 minutes is the time that has passed, and our half-life for each time we'll cut in half is 3.19 minutes. So we end up getting 15 divided by 3.9, 19, 4.702 half-lives have passed. So this thing had a chance, Krypton 89, cut himself in half about almost 5 times. So you think about a starting amount being 100%, well, the end amount here of that parent product, well, it cut itself in half, 50, half again, 25, half again, 6.25, half again. So we're looking at about 3-ish, be my guess, just by thinking about these numbers here. So if you want to solve for N, the current amount, I'm going to say, well, N, and we're going to use kind of a percentage here. So if I don't have a starting amount, I'm going to say, well, 100%, and then N being how much percent is there currently. So I'm going to say 0.5 to the power of 4.702. If you work that through, you get 100 times 0.5 to the power of answer 4.702, and we end up getting 3.84%. Well, 3.84% would be the parent isotope. That's what's left of the parent. So in other words, this is the percentage of the parent. 100% minus that would then give us the daughter. So percent of would then be 96.2%. All right, let's take a look at the next one. A 300 microgram sample of strontium-94 decays to 37.5 micrograms in 4.8 seconds. What is the half-life period of strontium-94? So what is the period of that? So in the curriculum, it says we should be using non-logs to solve this through, so we don't need to be using logs. If you know how to use logs, that's great. But what we need to think about is somehow 300 is cut in half so many times to leaving us with a 3.75. And in terms of physics 30, they're always going to be perfect numbers. So if you think about cutting 300 in half, well, 300 after 0 half-life. So I'm going to make a little table. This is my method to solve this one through. Number of half-lives. And then this is the amount. So 0 half-lives, we have 300. After 1 half-life, well, that cuts in half, 150. After 2 half-lives, we're left with 75. And then 75 divided by 2. Oops. Sorry. 3 half-lives have passed, giving us 37.5 micrograms. So here we see that exactly 3 half-lives have passed. So if 3 half-lives occurred in 4.8 seconds, we should be able to figure out, well, how long is a half-life? So in other words, we're saying is N is equal to the time divided by the time for the half-life. So if I want to solve for the half-life, that's just going to be equal to time, 4.8 seconds, divided by the number of half-lives that have occurred, which is 3. So 4.8 divided by 3 gives us a nice 1.6 seconds. For your answer. Okay, so you can try this out using logs, but once again, that could be a waste, because in this case, we can solve most of these questions out just by using the table method, saying, well, what happens if I cut in half? Divide by 2, divide by 2, divide by 2, until we get to the answer that we're looking for. All right, so how can we use a graph to determine this out as well? So remember we said, well, 100 is our starting amount. So I want to find the point where we're sitting at 50. So 50, which means half of the material is now gone. So if you go down here, we're going to see approximately what number this refers to. So if this is 1, 2, 3, 4, we're looking at approximately, I don't know, 2.75, 2.8, somewhere in that. And that's going to be years. Another way to kind of confirm this is, well, we can do it again and say, well, 25%. And that's sitting at just a little bit beyond 5. So we're looking at approximate values here, but we can pretty much get a pretty good idea of how this would solve out if you kind of repeat this pattern over and over. Okay, doing the same thing here, but now this is the daughter isotope. The daughter isotope works the exact opposite in this case. So we're looking at around the 50%. So if we have 50% daughter, that means we have 50% of the parent isotope as well. And then we're just going to bring that value down and then try to figure out what that refers to. So once again, a little bit of a scale here, times 10 to the power of 9. So if this is 0.5, 0.6, 0.7, 0.8, so maybe it's 0.74 times 10 to the 9 years. Okay, once again, that's going to be an approximation. All right, so try the half-life questions out, and then we'll try some other videos talking about particle paths.